Hello everybody, welcome to my channel CS Revision and Notes. So already we have seen four units, that is operating systems, networks, data structures and algorithm, and database management systems. So today we'll see software engineering. Okay, so let us start some. Here too I have taken 5 problems. We'll solve them one by one. Okay, so first problem, I'll read out the problem. A server crashes on an average once in 30 days, that is the mean time between failures, MTBF shortened form. Okay, mean time between failures is 30 days. It takes 12 hours to reboot, that is mean time to repair, that is 12 hours. The availability of the server is approximately. So the options are given. So this is a formula. Okay, so here what is the formula? Okay. Software availability which is equal to mean time between failures, that is what's the mean time between failures, MTBF. Mean time between failure plus mean time to repair. So here what is given, mean time between failure is what is 30 days. So and then mean time to repair is 12 hours. So first we convert the 30 days into hours. So it will be 30 into 24. So one day has 24 hours. So 30 days, 30 into 24 will convert to hours, and then this will write it as hours itself. So 30 into 24 plus mean time to repair is 12 hours. So 12. So what is this value? That is 24 into 10, 24 into 30. So value will be 72. So 720 by 720 plus 12, which is equal to 720 by 732. So the value will be 0.983. So this value is 0.983. So here they given in percentage. So percentage means going to multiply by 100. Okay. So multiply by 100, it will be 98.3%. So the answer is the third option, that is 98.3. Okay, next problem. So next problem, the number of function points of a proposed system is calculated as 500. Suppose that the system is planned to be developed in Java and the LOC per FP ratio of Java is 50. Estimate the effort E required to complete project using the effort formula. So formula is given, E is equal to A KLOC to power B. Values of A and B are given. A and B are constants. Okay, in the effort formula, A and B are constants. So the values are given 2.5 and 1. So we have to find out what is the effort. Okay, so the formula itself is given, so we can find out. So first we need to know what is the value of KLOC. So here they are given LOC by FP. LOC by FP ratio is given as 50. So LOC we don't know, but FP we know. So FP is given, the function points is 500. So LOC equal to 50 into FP. So 50 into, what is the number of function points? Function points are going to be 500. So 50 into 500 is equal to 25000, which is LOC. So LOC equal to 2500. Okay, that means KLOC, what will be the KLOC? It is in kilo, that is KLOC in thousands, right? So it would be 25K. So you can write as 25K, no? So KLOC will be 25. Okay, now substitute KLOC in this formula, that is the effort formula, which is given effort E equal to A into KLOC to the power of B. So what is the value? A is given. A is given to be 2.5. So 2.5 into KLOC found as 25. 25 and B value is 1. So B value is 1 given. So 2.5 into 25, which is 625, means 62.5. So 62.5 is the value, the effort. Okay, so 62.5 person months is given. So 62.5 effort is in person months. So 62.5 person months. So the value is 62.5 person months. Okay, next problem. A software system has 940 modules. Greatest list 90 of these modules need to be changed. In addition, 40 new modules were added and 12 old modules were removed. Compute the software maturity index. Here we have to find out the software maturity index. So what is the formula for software maturity index? It is equal to number of number of modules before minus x by number of modules before. So number of modules here in this problem, number of modules before any changes is more modules is 940. Now x, what is x? X will be number of modules changed. So it can be added, deleted, and then changed. Anything can be. So here we find that 90 modules were changed. So 90. Next 40 new modules were added. So 40. And 12 old modules were removed. So 12. So this value will be 142. So x value is 142. So the software maturity index will be, so 940 minus 142 by 940. Here 940 minus 142 will be 798. Okay, 980 minus 1, so 798 by 940. So this value turns out to be 0.848. So this is the value of the software maturity index. So this value is 0.848. Okay. Next problem. See, given a software project was estimated. A software project was estimated at 350 function points. A 4-person team will be assigned to this project, consisting of an architect, 2 programmers, and a tester. The salary of the architect is rupees 80,000 per month. The programmer is rupees 60,000 per month, and the tester is rupees 50,000 per month. The average production for the team is 8 FP per person month. What is the projected cost of the project? So they are asking the cost of the project. So to find out the cost of the project, here the salary of each and every person is given. So we need to know how many months they have been used. So when we calculate the number of months, then we can find out the projected cost. Okay. See, See, they given, so total estimate for the project is 350 function points. So total estimate, total function points, total estimate is 352 function points. Of these, they given the average production of the team. So the team produces 8 function points per person month. So average production is 8 FP per person month. So you want to calculate what is the effort. So if you, that is the per person month. So yes, person month. Okay. So if you want to calculate the effort, so effort will be how much effort in person months. So how will you find out the person months? So you divide this 352 by 8. So 352 by the 8 average of the production will give you what? See, this is FP, this is FP per person month. Hence when you divide, you will get the number of person months. Okay, so 8 divided by means 352 divided by 8. 350 divided by 8 will be what? See, 8 4 so 32, 8 to 4, so 44. So it will be 44. Then this goes up, so it will be 44 person months. Therefore, it will be 44 person months. Now, we found out the number of person months, and they're given as at least a 4-person team. Okay, so number of persons will be number of persons is 4. So we know the number of persons, we know the number of person months. Now we can find out the number of months. Therefore, number of months will be what? Number of months will be 44 person months by 4 persons will give you number of months. So here the number of months will be 4 by 44 by 4, which is 11. So 11 months. Okay, so it will be 11 months. Next, they given the salary of the architect, then 2 programmers and a tester. Okay, here the salary of the architect is 80,000, salary of the programmer is 60,000, salary of tester is 50,000. Here there are 2 programmers, right? 2 programmers are given, so here into 2, so which is 80,000 plus this is 1,20,000 and this is 50,000. So if we add all these, we will get total value will be 2,50,000. So 2,50,000 is what? This is for 1 month, per month. So expense per month. So they've asked the project cost for the project. So the project takes 11 months. Okay, so 11 months is the time. So the projected cost of the project. The projected cost of the project will be, that is 11 months into 2,50,000. So the value will be 2,750,000, which means 27,50,000. So here projected cost of project is rupees 27,50,000, which is the projected cost of the project. So Next, a flow chart is given. Okay, here a flow graph F with an entry node 1 is 1 and exit node is 11. So this is the flow graph. Here we have to find out the values. So what is asked is first question. So first question, how many nodes are there in the flow graph? So what are the nodes? How many nodes are there in the flow graph? Here we find that here this is a node, but two labels are given 2 3, but it is be taken as a single node only. So 1 2 3 4 5 6 7 8 and then 9. So number of nodes will be 9. Okay, so this is one node. This is we have taken as one node only. 2 3 and 4 by we have taken as one node, single node only. So 1 2 3 4 5 6 7 8 9. So totally there are how many nodes? There are 9 nodes. So the nodes in the flow graph is 9. So what is the cyclomatic complexity of the flow graph? So what is the cyclomatic complexity? So cyclomatic complexity. So cyclomatic complexity can be found by the formulas. First is the edges minus number of nodes plus 2k. That is k is the number of connected components. So here is number of connected components. For a connected graph means it is one only. So now we have to find out how many edges are there, how many nodes are there, and then add it. Okay, so e minus n plus 2k. Now we'll find the number of edges. So how many number of edges are there? See, we'll find the number of edges is, see, 1 2 3 4 5 6 7 8 9 10 and 11. So again we'll find out. See, 1 2 3 4 5 6 7 8 9 10 and 11. So there are 11 edges. So number of edges is 11. Number of nodes. So number of nodes we already found, no, in previous question. So number of nodes we found as 9. So number of nodes is 9. In question found number of nodes is 9. So I have the value of 9 plus 2k. So k is 1, I told you. So connected component means it is 1 only. So it's connected graph. So k is 1. So 2 into 1. This is 11 minus 9 plus 2. So 2 plus 2, which is equal to 4. Okay, this is one method for finding the cyclomatic complexity. Next, we can find out by the number of regions. So number of regions. So how to find out number of regions? This is the bounded region, and we have to include one unbounded region only. So unbounded region, one bounded region and one unbounded region. So number of bounded regions. So how to find the number of bounded regions? Here, which are bounded. See, take this one. Here you find this is one region 1, 2, this region 3. Here it is bounded only, no? So 3. So 3 bounded regions are there. This we can't take. Okay, so there are 3 bounded regions and 1 unbounded region. So bounded regions is 3 and 1 unbounded region is 4. So number of regions is 4. Next you can find out the cyclomatic complexity through this formula, number of regions or the number of predicate nodes. So what are the predicate nodes? Predicate nodes means decision nodes. Which nodes are having decision points? So if you see the graph, each points are decision points means when that node means we have two paths, then that is a decision point. See here, one has two ways, right? Can go here or can go here. So decision one is a decision node or predicate node. So we take one, that is the node 1. Next see 2 3. So 2 3 is also decision node because it has two branches, right? Two branches coming from this one. So another node which is 2 3. Next number of predicate nodes will be okay. So next which are the predicate nodes? This one is a node, two three is a node. Now 6 is a node because this also has two outside node. One goes to 7, one goes to 8. So 6 is also a 6 node is also it's also a predicate node because it has a decision making node. Okay, so now to calculate this value, number of predicate nodes plus 1, so you have to include 1. So this value is 3 plus 1 which is equal to 4. So number of predicate nodes is 3 only. So number of predicate nodes is 3 only, but we have to add 1 so to get the cyclomatic complexity. So number of predicate nodes plus 1. So here too the formula will be number of predicate nodes plus 1. Okay, this is number of regions is bounded regions plus 1 unbounded region. So number of predicate nodes. So I find all the values, we get the same value for the cyclomatic complexity. So whichever way you calculate, you get the same value. So we find out the cyclomatic complexity to be 4. So what is the cyclomatic complexity of the flow graph? That is 4. How many regions are there in the flow graph? So next is how many regions are there? So we already found out, no? Number of regions, 3 bounded regions and 1 unbounded region. So totally it is 4 regions. So number of regions in the flow graph will be what? It will be 4. So this is the answer. Number of nodes in there are there in the longest independent path. So how many nodes are there in the longest independent path? So we take the path, find out the number of nodes. I will find out the number of nodes in the longest independent path. Okay, so here we'll find out the longest independent path. So you can come here, then from here, and then 6 8. So anyways you can take, so from here 6 8 9, then 10, then from 10 you go to 1, and then from 1 you can come to 11. So I write the path. So they asking not the number of edges, they asking number of nodes there in the longest independent path. So you have to find the number of nodes. So we'll write the nodes one by one. Okay, see from this you start from one node. Okay, one node is there, then you go to 2 3 node. Okay, next where you'll go to 6th node. So you'll go to 6th node, then you'll go to where? You'll go to the 8th node. 8 or 7 anything you can take. So 9th node, then you go to the 10th node, then you go to the again to the first node, then from first node you go to the 11th node. Okay, so they asking number of nodes in the longest independent path. So this is independent path, goes here and comes here, then goes here. So this is independent path. So if you have to find out the number of nodes, so add the number of nodes. See 1 2 3 4 5 6 7 and 8. So there are 8 nodes. So 1 is included because first time 1 is coming this here, after it goes here, and again from 10 it goes to 1. Okay, so you have to take 1 again as a node because it is in this path. So then 1 goes to 11. So number of nodes is 8. So number of nodes in the main part is 8. And answer is 8. Next, how many predicate nodes are there and what are their names? So they asking how many predicate nodes are there and what are their names. So we find that we've already found out the what are all the predicate nodes we have found out. Let's see. Number of predicate nodes. I told you no, predicate nodes means decision nodes. So we already found out there are 3 predicate nodes. So what are the 3 predicate nodes? So first one I told 1. So 1, that is the node 1. Okay, next another node is 2, 3. See, first node is 1. Next this node, this is 2, 3. So 2, 3 is a node. 2, 3. There is another node. Next which is addition 6. 6 is a decision. This is not a decision, and this is not a decision. 1 is a decision node, 2, 3 is a decision node, and 6 is a decision node. And then another one is which is 6. So 1, 2, 3 and 6, these are the predicate nodes. So number of predicate nodes will be 3. And the answer is, the option is here, how many predicate nodes are there and what are the names. So it is 3, which is 1, 2, 3 and 6. It's 1, 2, 3 and 1, 2, 3 and 6. So there are 3 predicate nodes. Okay, I hope this was helpful to you. And next we shall see artificial intelligence. Okay, I hope this was helpful to you. If you have any doubts, basically in software engineering you have all these problems are taken based on a formula. So you need to know the formulas. If you know the formulas, means if they ask these type of questions, means directly you can apply and you can get full marks in this one. So these are easy sums which can be learned easily. So that's why I've taken these sort of sums. Okay, so those who are doing net set exams, so this will be useful to you. So please share your feedback and please share this videos with your friends, those who are in the competitive examinations, who have applied and who are waiting to take up the exams. Okay, so next class we can take up artificial intelligence with some simple problems. Okay, thank you.